Hey guys, welcome back. In semester 2, we're going to be starting with Unit 3, which is Chapter 6, 7, and 8. So we're going to be starting with Chapter 6, and in the first section, we're going to be talking about polygon angle sums and the theorem about them. So, polygon angle sums basically says the sum of the interior angle measures of a polygon depends on the number of sides the polygon has. So, a triangle, all the angles inside of a triangle is going to be less than the sum of all the angles of a square or a pentagon or a heptagon or something like that. So the more sides a figure has, the more bigger the sum of the angles is going to be. So this theorem, which is called Theorem 6.1 or the polygon angle sum theorem, says the sum of the measures of the interior angles of an n-gon, so any side of a polygon, is equal to n minus 2 times 180. So let's say I had three. Let's say I had a triangle. Triangle is 3 sides, so I'd put the 3 in here, and then 3 minus 2, which is 1 times 180. Okay, so let's try and go through a problem here. It says, what is the sum of the interior angle measures of a heptagon? Now, a heptagon is going to have 7 sides for that. So the sum, using this theorem, is n minus 2 times 180. And we plug in the 7 to get, for the n, so that's how many sides we have. And then 7 minus 2 is 5, 5 times 180 is 900. So sum of the interior angle measures of a heptagon is 900. Now we're going to go on into determining what kind of polygons we have. And there are 3 different types. Okay, so these are the 3 main types of different polygons that we can have. Remember what a polygon is? A polygon is going to be any shape that you can think of except for a circle. So any shape you think of, as long as it doesn't have any curved sides, it's basically a polygon. Okay, so equilateral polygons are going to be ones that are going to have only the equal sides. So equilateral, equal sides. Equal angular are going to have the ones with the all the angles are going to be congruent. And the last one is regular, when they're both equilateral and equiangular kind of sides. Next we're going to go into how to find the individual angles of each of these different polygons. Okay, so now we can go into a theorem which will help us find the measure of angles of each individual angle of different polygons. So the theorem is corollary to the pi angle theorem, and the theorem says that the measure of each interior angle of a regular n-gon, so whatever polygon side is n minus 2 times 180 divided by n, or the number of sides that we have. So we have a word problem associated with this one. It says the common housefly has eyes that consist of approximately 4,000 facets. A facet is basically just like a piece of the eye made up to make up the regular eye. Think of it as like a piece of a beehive or something like that. So each facet is a regular hexagon, which is 6 sides. What is the measure of each interior angle in one hexagonal facet? So we're going to use our theorem, n minus 2 times 180 divided by n. And then we're going to plug in our number, which is 6. So we do 6 minus 2 times 180 divided by 6. And then 6 minus 2 is 4 times 180 divided by 6. And then we can simplify here, or we can do whatever, but ultimately our answer is going to be 120. So we can say the measure of each interior angle in one hexagonal facet is 120 degrees. This should say degrees. Okay, so next we're going to go into a problem where we're given a non-regular polygon with different angle sides, and we're asked to find out the last remaining angle. Okay, so this question is asking what is the measure of y in the pentagon today. So this is our pentagon today, T-O-D-A-N-Y. So they're given 4 of the 5 different angles. So we can start off by saying that the measure of angle T plus O plus D plus A plus Y is equal to 5, because it's a pentagon, 5 sides, minus 2 times 180. And now we can fill in what we know and solve for what we want to know, which is angle Y. So we know angle T, 110, O is 90, 120, 150, and finally Y. Then we can solve this side. 5 minus 2 is equal to 3, and then we have to times by 180. So in the next step, we're going to be adding all these different up. So 110 plus 90 is 200, plus this is 320, plus 150 is 470. And then 3 times 180 would be 540. So we get 470. Plus the measure of angle Y equals 540, and we could solve for that, and we get the measure of angle Y equals 70 degrees. The next thing we're going to be doing is figuring out what would be on the outside of these angles. So on each exterior angle, there's a special rule about polygons, is that the sum of all the exterior angles is always going to be 360 degrees. Okay, so now this problem goes into exterior angles of polygons. So you can draw an exterior angle of any vertex to a polygon. So I can go out here and draw an exterior angle like that. The figures below show that the angles of any vertex will always equal 360. So I have this triangle here. Let's start with this one. The inside angles are 100, 50, and 30. 100 plus 50 plus 30 will be 180, so that checks out. Now the exterior angle of the 100 is going to be 80. The exterior angle of the 50 will be 130, and the exterior angle of the 30 is going to be 150. If we take those exterior angles, we'll get a sum of 360. Similarly, over here, if we have a quadrilateral, which is 4 sides, 65, 105, 81, and 109, this should equal 360. Then we take the exterior angles of each different one. So exterior angle of 65 is 115, of 105 is 75, of 81 is 99, and of 109 is 71. Take these exterior angles, 115 plus 75 plus 99 plus 81 does in fact equal 360. Now we're going to go through and name the proof of this and go through a problem, and that will be it for today. Okay, the last thing is called the Polygon exterior angle sum theorem. So what that is, for this means is the sum of the angles of the exterior angles is going to be 360, like what we just had before. So we take this example of a pentagon. Taking the example of a pentagon, we have 1, 2, 3, 4, and 5 exterior angles. So whatever number of sides we have, we're also going to have the same number of exterior angles. Those angles sums is always going to be 360 degrees. So if we take, so what is the measure of angle 1 in the octagon below? So here we have this beautifully drawn octagon with all these angles in here. Here's 1, 2, 3. This is a 4, 5, 6, 7, and 8. What would be the sum of just angle 1 here? Well, we know the sum of all of these angles is going to be 360 degrees. Now, since we have 8 different angles and we want to find one of them, we can divide 360 by 8. So we get measure of angle 1 is 360 divided by 8, which is 45. So angle 1 would be 45. Actually, all of the angles will be 45 for this, because since it is a regular octagon. So you may have noticed that we had some questions in here that weren't in the video, kind of questions that have to do with the topics. So what I'm going to do from now on, I think, is have those kinds of questions. If people get them wrong, we're going to go over them in class before individual work. Then I'm also going to leave the last question at the very end for you guys to say, I want to go over this in class before we start individual work. All right. So that's what we're going to be doing today. Hopefully, you guys watch this before the class, and not most of you. I have a feeling most of you guys are going to be watching this in the computer lab. All right. Bye bye.